So today's lecture is sort of a just kind of a cover-all of a few chapters I think that are important. So we're going to be talking about LINQ and some of the technologies that lead up to this idea of what's called LINQ. And so lecture is just going to combine a lot of those ideas. And so with this particular example that we're going to be going through, what you'll notice is that I've just got buttons that, behind each of these buttons tell you these various concepts. So the first thing we're going to be taking a look at is the idea of implicitly linked local variables. And so implicitly linked local variables allow us to use what's called the var keyword. And so the var keyword allows you to declare variables whose type will be implicitly inferred. So what do I mean by that? Well, let's write a statement like, using the var keyword, I equals 1. So what this actually does is exactly the same as saying int I equals 1. There's no difference between the two. The var keyword infers for you automatically, and you'll notice it actually shows that it is an integer in IntelliSense. So it is strongly typed. This is not a variant, this is a var. It can be variable type. And so in something like JavaScript that has a variant data type, it can hold all kinds of different data. That's not what this is. The var keyword in C# implicitly infers what this is going to be. So it figures out the value that you're using to set this, and so it'll actually use that data type. So for example, I could say s equals, this is a string. And so the var figures out that you've tried to assign it a string, so you'll notice it is a string variable. Another thing I could also do is something like, integer array equals a new, and we'll say array, we'll assign it 1, 2, 3, 4. And so this actually figures out, hey, that you want to instantiate a single dimensional array of integers. And so what you'll notice down here that I'm doing to prove that is I'm actually saying i.getType.toString. So this will print out int, this will print string, and this will print out integer array for the types that they are. So I've seen people use the var keyword like to instantiate a lot of these things. I generally don't recommend that within your code. I like to explicitly do it. You can, and it works just fine. But we're going to see later on when we get into LINQ, where this is actually useful. So now let's take a look at what are called anonymous types. So anonymous types allow you to sort of inline create a class that you've never actually created somewhere else in your code. And it's sort of a way that inline you can, inline in this method, you could create the structure for a class because you just want it to hold data. There's not going to be any methods in it. You're never going to use this class again. You just want to be able to create a class to hold data. And that's its only job. So what we can do now is, again, we can use that var keyword. Let's say we want to build a car, which should sound familiar to you. So now we say new. Now what you do is you just say open bracket. And now you can define the properties you want to use. So for instance, I can say color equals red. And so this is going to create a property within this class, this anonymous class that it's creating for you behind the scenes. It's anonymous because you'll notice there's no class name anywhere in here. You're just creating this in-memory class that's anonymous to hold some data. And so we can also say make, for instance, and say like Ford. We could say, B has four-wheel drive. Set that equal to false. We could also say inum wheels, like we've done before. Set that equal to 4. And so what this will do is it just allows us in memory to have this little car anonymous type. And you can see when I highlighted it, it does say it's an anonymous type. But now when we use it, you'll notice how I say car.color here. It's actually read-only. So these are all read-only properties. We can never actually set the data in our car class. So we can pull color out, for instance. So we can say, string s color equals, and be able to pull that color out, but we can't actually set the color. And then here, again, I'm just displaying the type of this anonymous type. And it actually, behind the scenes, it does actually create a class for you. but it's some weird, just unreadable name that it just doesn't make any sense. So the next thing I want to take a look at is something called extension methods. And so what extension methods are is that you can extend classes, or types that have already been written. So let's say, you got a piece of code from someone, and you're supposed to maintain this code. However, there can be a lot of headaches if you just open up this code and start modifying it with, proving to someone else that you didn't actually, change or hurt this code and broke it. So what you could do is you could use an extension method to it's almost like packing on clay to a statue. In this instance, what we're going to do is we're going to be adding on methods to the string type and integer type. And so, when you say s dot, it gives you all these methods because it inherits from the base class, or the string class, has these methods in it. But what if you wanted string dot and some of your own methods to pop up? That maybe you wanted to manipulate this particular string, or it does something else for you, some useful string type method. Well, what you can do is you can create a class. For instance, I have created this one called extension methods, and you notice you have to make it static. And then what you can do is you can create these methods, and they both are static. And so you notice this first one I've chosen to return an int. I've called add one to string value. And so this is kind of like a strange syntax, but this is how you tell it that you use the this keyword, and you say, okay, for the string type, I'm going to add on this method to it. And you'll notice it takes in this parameter s my string. So if we come back over here and I say s dot and I say add one to string, you'll notice that it adds one to the string value that you did here. So you can see, so you call this method and we're saying, okay, by using this string, it's actually going to add this method to the string class, just like how we saw right here. So add one to string value. So it's just a way you can sort of pack on a method to a type that already exists. The same way that I'm doing down here, you can see here we're extending the integer type, where you say this int, and then this int, and this is my int is the integer that you're currently working on. So that's how it knows that you're adding on to the int class, and this is the integer you're working with, is this here. And you can see I'm subtracting one. Up here I'm adding one, pulling out the string and adding one to it. So it looks kind of strange, but I've added on these methods to the string. So I can say add one, and so when I say s.add1, you can see that it actually pops up with that extension method. And you'll see here where it says extension. So that's where they've done that. They've taken an existing type and they've extended it. And the reason we're learning about this is because that's how LINQ works. So we're going to be learning about LINQ here in just a second. And what they've done is they've extended on all these what are called LINQ methods to all these existing types. So the next thing we want to look at is anonymous methods and lambda expressions. And so this is another way that we can deal with delegates and be able to pass information around. And so you'll notice here's a delegate, and we know this syntax before. We've just instantiated this. We've created a delegate. The signature is the method has to return an integer and take an integer as a parameter. So now what we do is, this is the way that we've been using them already. And so you notice here's the delegate. I instantiate it and I point it to this square method down here. So this shouldn't be anything new. We've been working with delegates. You instantiate this delegate type and you tell it which method you want it to point to. Then you can use that variable and you can pass in the value, and it's exactly the same as if you're calling square. Well, there's other ways that in line you can create other methods. And so again, let's say you're creating a method and you're only ever going to want to do something with it right here, or you're going to pass it to someone else. So it doesn't make sense to really have to create a whole separate method to do that. Well, you can write what are called delegates in line, these inline anonymous methods. And so what I can do here, let me just paste in some code, tab this over so it makes it a little more readable. So what we can do is, so you notice just like we did up here, where we said, delegate to hold a square method, you notice it's still of my type delegate. So we're saying that this delegate has to still meet this signature. However, we don't want to have to go off and write this method somewhere. We just want to pass it into a method, or we want to store it in a delegate. So we can use this delegate keyword, pass in the parameter here, And then we just literally write our method right in line of this other method. So this is what's called an anonymous method. And you can see here, we're just calling this, and it's just like calling this line of code here, or these codes here. Now, there's a newer way of doing it, and it's just sort of preference, but it's with using something called lambda expressions. And so you notice with lambda expressions, you first define your parameters, you use the equals greater than sign, and then you can write your code. And this is what are called lambda expressions. But it's just another way of writing anonymous methods in line. Down here, we're just going to learn about auto-implemented properties, and we've seen these already in a lot of the book examples. And what's nice about auto-implemented properties is that when you define them, it behind the scenes will create a private variable for you. But a lot of times when you're creating a private variable, then you create a get and set for it. Most of the time the get and set do nothing but return and set that value. A lot of them you don't even have to do validation on. So this is the shorthand notation of hey, all I really care about is this property. So C# creates a private variable behind the scenes, but you only ever access its public property. And that's what auto-implemented properties do for you. And so now, learning these things, we can now take a look at how LINQ works. So you have to use the system.LINQ namespace in order to get access to LINQ. So what is LINQ? LINQ stands for Language Integrated Query. And what it allows you to do is you can write query expressions to extract data from objects or databases and things like that. So it's really similar to how SQL is a query language for a database. Well, LINQ is just a query language where you can query, let's say, an array or some sort of list or collection, and you can write a query for it to pull data out. So rather than you writing a for statement with ifs inside of it, so a LINQ would be the equivalent of you have a for statement that iterates through a collection. So for each string in this string array. And as it loops through, you have an if statement that says, if my string equals this, or let's say you're looping through an integer array, then you have an if statement that says, if my string is greater than 4, save this particular integer away. But you can use LINQ to describe that in a query language rather than having to use a for statement and if statements. So there's what are called LINQ to objects. So LINQ to objects is just like what I described. You're using LINQ to query objects like a collection, some sort of array. There's also LINQ to XML. So you can use a query statement to query an XML file to be able to look at the tags and be able to query out only certain elements within an XML file. Or there's LINQ to SQL. And so LINQ to SQL uses the entity framework within .NET. And what it allows you to do is its entity framework maps your SQL database to in-memory classes in C#. And then what you will do is you use LINQ to SQL to just query these objects in memory. Or you can actually use LINQ to SQL to query the database directly, and then LINQ will actually create the SQL for you to query a database. It's kind of interesting. And so let's take a look now at LINQ. So the first thing we need is some sort of collection to query. So here you notice here's just a regular integer array. And so now I'm just going to iterate through all the elements to print them out. And so now we're actually going to write an array or a LINQ statement. You notice here's the var keyword. Now we use the var keyword because it needs to figure out for us what type we're returning here. And it can actually figure that out from your statement. And what this actually returns is what's called an IEnumerable collection. So all that means is that it's able to be enumerated through. It's just going to be a collection of integers is all this particular. It's just basically a list of integers is essentially all this filtered variable is. And so here's the syntax for LINQ. Always the first statement is from. So this is the equivalent of your for each statement right here. So you're saying from value in values. It's exactly the same as saying for my integer value in values. It would be exactly the same. Now in LINQ, you notice it's a little bit different than an SQL to a database where SQL always starts with a select statement. Well, LINQ always starts with a from statement. Now the reason they chose it to do this is for IntelliSense. So if you use the from statement on your very first line, then it knows the collection you're working with. So it's able to then figure out IntelliSense throughout the rest of your LINQ statement, which is quite useful. And that's kind of a flaw when you're writing SQL going to a database, is that you're writing your select statement first so it doesn't know what you're selecting from in a lot of cases. So we say from values, so this is going to be like the iterative value here in values, which is our collection. Then we can put whatever, where or compound where statements we want here. So where value is greater than 4. And so what do? We just select the value. So this is the select statement, just like SQL. So what this statement says is, hey, select every value in this collection that is greater than 4. And so see how you can query this statement? So it's a little bit more readable, and it's kind of a little bit nicer rather than having to write for each statements, especially if this gets really complicated. And so then what we can do down here is we've got this for each statement that you'll notice that, so now we've got this filtered variable, and so filtered only contains a collection of the values that are greater than 4. So you'll notice 9, 5, 7, 8, 5. So only those subset are going to be into filtered, and so this is just a collection of integers, and so then we're looping through those. So let's take a look at another one now. So we're doing that same thing from value and values, and now we're just ordering values. So this, you're able to sort in SQL, and you'll actually notice that you can actually sort ascending or you can sort descending. It does ascending by default. So there's even more keywords that you can tack on here. And so this is a really easy way that you can sort that array. And then down here it's just outputting that sorted array. So now here it's showing you that same thing, but now it's descending instead of ascending. Then we come down a little bit further and we say, okay, var sort and filter. So we have our same for value and values, where value is greater than 4, order by value descending, select value. So here we're only getting the values greater than 4, but oh, by the way, I also want you to sort them when you give them back to me. Now, the one thing you want to understand about LINQ is that it's what's called lazy initialization. And it sounds kind of strange, but what it really means is that this statement right here does not actually run this query. So if I were debugging and I pressed F10 on this line of code here, it does not execute this query. This query does not get executed until you start iterating through this collection. And it's kind of strange, but there's reasons it did it this way. And so you just need to know that this query does not get ran here, it actually gets ran here. So let's go ahead and take another look, an example from your book. So in this example, we're going to be querying a list of objects. So the first thing we need to do is understand this employee class. And so the employee class just has a first name, a last name, and then it also has this month salary down here, and then it overrides the toString. So it's just an employee with first name, last name, and their salary. So we come over here to our main form. It instantiates an array of employee objects, and then it just instantiates a bunch of employee objects to fill up this employee array. So this should be nothing new. But now that we've got this collection here called employees, again, how would we loop through here and pull out, people with only a certain base salary or something to that nature? We'd have to do a for each statement, go through every single one of these and do if statements or whatever else. But now with LINQ, we can just simply query this array here. So let's come down here. So let's filter where it's between, $400,000 and $600,000. And so what we do is we say from E and employee. So now E is not just simply an integer like in the previous example. This actually holds the entire employee object. So this is saying for each employee in employees is what this is doing. Okay, so I'm saying I'm looping through my employees collection. Now I can say in my where statement where E dot anything I want. So where E dot monthly salary is greater than or equal to 400,000 and E dot monthly salary is less than this. And so we can also, you can compound this any way you want. E dot, first name, equals something if you wanted to, ABC, something of that nature. So you can access any of those variables and tack them on. And then, so here's the where statement. And then we use our select statement. You'll notice that we're actually selecting the entire object, just not simple pieces of data, the entire objects of data. So this will pull out all of the employee objects that meet this criteria between 400,000 and 600,000 or whatever it is. And so let's come down here and then another one where this is just sorting the employees by last name and then first name. So hey, this is what we're going to work with in our LINQ query. Order by the last name, then the first name. So if there's ever two of the same last names, which you'll notice we have 3 indigos right here, so they'll be sorted by last name and then first name. Now what you'll also notice is that I get this collection back right here. So this is name sorted. And now when I say this collection dot any, notice that this is what's called an extension method, like we just learned about. So in this IEnumerable type, they've actually put an extension method there called any. You can see it determines whether a sequence contains any elements. So it's essentially saying, hey, did this return any values to me? If it did, return the first value. You can see here's another extension method called first. Returns the first element in a sequence. So in this collection here, name sorted, it's going to return the first element in that collection. Now down here, we're saying, okay, from all of our employees, select e.lastname. So now we're not selecting the entire class. We're actually just selecting last name. So this is going to be an IEnumerable collection of strings. And you see we select it, and sure enough it is. So it only collects the last name. And then we can see another extension method. We're saying last name dot distinct. So we're actually only going to print out the distinct last names in this particular for each statement. Then the last example of this one, we have all of these. Now we're saying, okay, what we want to do is, you know what, we're really not interested in their monthly salary. We just want to print out a list of first name and last name. So you can see what we're doing here is we're using those anonymous types that we just learned about. So we're saying select new, and then here's the data I want you to fill up in my class. e.first name, comma, and then we're saying this is the name of the property, or else it will default to first name. And here we're saying the property name is last, set that to e.last name. So this is going to go through and it's going to create an in-memory class of just this data, the first name and last name. So this collection will not have this data over here. So it's a way, and again, so you'll notice the reason that we have anonymous types because of LINQ is that, you know, we don't want to have to generate a whole new class that we're going to write down below or some other file that contains, you know, just first name and last name. When this is just something we want to select some data out and this is the structure we want to hold it in. Then you notice right here is where we actually print it all out. So now this is the last example of LINQ, and you see here we're actually querying a list of strings. So again, any collection you can query with LINQ. So it's really flexible. So here we're just going to add some different strings, and you can see their names of colors with some upper and lowercase letters. And so let's add a little bit more complexity to our LINQ statements, which gives us power. And so we're going to say, okay, from item and items, let uppercase string equal item.toUpper. So this is a way of declaring a variable inside of your LINQ statement. So let is sort of like instantiate a variable is what this really is saying. And so you'll notice this is just a string here. So it's saying, okay, inside these items, what I'm going to do is take this item, make it uppercase, and then go on to my where statement where it says uppercase string starts with R. So we're doing this because you'll notice that here's a lowercase r and an uppercase R, but we still want to extract data from both of these. So we can say, okay, now we're just dealing with uppercase data now. So see where it starts with R, and then order by that uppercase string. Select the uppercase string. So what this will do is it'll actually return the values rust and red, and all the letters will be uppercased with this particular statement. And then it prints it out. Now here's where that understanding of lazy initialization comes in. Because you'll notice what happens is that here starts with R, and we print out the values. So this will actually print out rust and red. Then you'll notice what it does, it actually adds 2 more items to this collection up here. So now we do another for each statement through this original collection here, and what this actually does is it reruns this query. So the first time it prints this out, it's going to say rust red. That's what this is going to print out. They add 2 more items. Now if we loop through that same collection here, it actually runs this query again, which means now it's going to say rust red ruby is what it's actually going to print out. So let's take a look at that. And so when we run it, you'll notice rust, red and rust, and then the next time through it actually prints out red, ruby, and rust. And so it's just kind of a little nuance with LINQ, that lazy initialization, that if you don't understand it and you're just trying to actually loop through this again, you could kind of create a bug in your program because you didn't understand that you added other items to it, and this actually reruns that query. So it's going to add in this other value. So that's what LINQ could do for you.